Hello, greetings. Today the topic is Linux CNC in connection with EtherCAT, and I want to take you along and show you how you can gain experience with simple steps without needing access to a complete system. We will start with a small presentation and first clarify what is Linux CNC. Linux CNC is an open source software that allows machines to be controlled. The whole thing naturally happens on Linux and has a few advantages. The main features of Linux CNC are, for example, that it can control a variety of machines. Even in the standard case, that means there are pre-configured things, examples with which you can control, for example, lathes, milling machines, and so on. Additionally, there is also a huge community, a forum within Linux CNC that provides a lot of support. At this point, Linux CNC can process G-code like any other CNC control. That means CAM systems output G-code, and Linux CNC processes this and ultimately executes it. Linux CNC is also not as old as it used to be, but there are now countless interfaces that offer advantages and disadvantages. But nowadays there are also, I would say, quite modern interfaces that, no longer look like Linux CNC. A significant advantage of Linux CNC, as I see it, is the use of the real-time kernel, meaning the ability to perform tasks in real time, such as control loops or certain queries or calculations that always occur at the same time. In my opinion, this is one of the most important aspects of Linux CNC, that time-critical issues can be addressed here. If you're outside the standard bubble, meaning you have a special machine, whatever it may be, or you have a special case with your machine, then Linux CNC offers the possibility, well, with programming knowledge, I would say, to expand the whole thing. That means if you are capable or know someone who can take it on, you can further develop Linux CNC for yourself and adapt it to your machine or environment. Ultimately, you could also say Linux CNC transforms a conventional PC into a powerful CNC control system. That's briefly checked off, and my mental image of Linux CNC is ultimately it's a construction kit, a huge Lego box that you can use to build a CNC control, and in my opinion, there are no limits. Okay, let's switch to the topic of EtherCAT. If I now say, okay, I have a PC, I install Linux CNC on it, and in this case, EtherCAT master, then I have a cool CNC control and can communicate with the EtherCAT devices via the Ethernet port. And here, for example, a few motors or an I/O module or a spindle, or I make the I/O module so that it controls the frequency converter of the spindle, however. But that would be, for example, a system for a gantry milling machine. And you can already see the wiring effort is minimized a bit because the communication takes place over the network cable. Maybe something technical. The Linux CNC machine is ultimately configured via the INI and HAL files, and with EtherCAT an additional point is the XML file. That means in the bus there are different participants, and it means it must be specified which participant is supplied with which data, and which data can be retrieved from the participant. And this happens here, so to speak, in the third instance with an XML file. Otherwise, when using EtherCAT, the INI and the HAL should be written just as if I were using the whole thing without EtherCAT. But that is, so to speak, my picture of a typical portal milling machine as it could be operated here with EtherCAT devices. Okay, my test setup today will be We don't have a real pizza, but I only have a virtual machine. We will set it up and install it. I have a USB to Ethernet adapter. That means for a test, it is completely sufficient. For a production environment, I would not recommend it. I have a Beckhoff coupler. You can now find it quite cheaply on eBay. And I have a few I/O boards connected to it. And this is basically my test setup. And it's also something that anyone who wants to start with EtherCAT can do. You don't necessarily have to set up a PC. You can also do everything with your existing PC in a virtual machine. Yes, here are the components as they are now on the table, and the steps will be: we will install Linux CNC, set up an EtherCAT master, and try to find the terminals from Beckhoff. Ultimately, EtherCAT always consists of a master and the slaves connected to it. And we can already see that the PC is essentially the master, and everything connected in the chain are essentially the slaves, the participants that are being operated. Yes, we have reached the end of the presentation and could ultimately move on to the practical part. So I have displayed an image here again of the Beckhoff EtherCAT coupler. Attached to it are the I/O slices. You see I have already connected the supply voltage. I have pulled a few wires so that we can dampen inputs and we will recognize outputs by the LEDs. Okay, let's jump into the practical part. Okay, so that we can install something, we need the Linux CNC image, the current one. That means I go to linuxcnc.org, select downloads, and then I can download the current image here. In this case, version 294. And that is also the basis for our virtual machine, for our virtual PC. I would also put this image on a USB stick to install it normally on a computer. But now we are building a virtual computer. That means I start a VirtualBox and simply press the new button here. So the first thing I need to assign is a name. That means I'll call it EtherCAT test. And I want to save it under a specific path. In this case, the files of the virtual machine should be saved in this folder. I select my image, that is the ISO file. And those are the essential points. Next, I will deselect the unattended installation here so that I can monitor the whole process myself. I jump into hardware and assign a few rudimentary PC properties. I want the system to have 8 gigabytes of RAM and I want the system to have 6 cores. It always depends on your PC, how many resources it has. I can allocate some resources from my PC for the virtual machine. So the next thing is the hard drive. I want to have 50 gigabytes of hard drive space. And now I can already press finish. Basically, such a virtual machine automatically provides the internet. That means during the installation, I also have internet and necessary packages can be retrieved. Okay, and now I can finally start this machine using the green arrow. And first the ISO will boot, and we see the boot manager of this ISO, and here I can install everything as usual. I select the start installer and will now be guided through the installation. The first thing is the language selection. Here is a reminder. The installation is basically the same as on a real PC. So for anyone who wants to install this on a real PC, they can follow along exactly here. So I first select the language. After that, I choose a computer name. I do not have a domain. The user is called CNC here. And now I choose an appropriate password for the user. Next comes the partitioning of the hard drive. I also stick to the standard here. That means I take the entire hard drive. I select my virtual hard drive here and leave everything on default. I accept the partition data and everything should be written to this hard drive. Now the system actually starts copying the data. That means data is now being written to the hard drive. This will take a little moment. So we confirm here by clicking Next. Now a few packages are being fetched and installed that are needed. Finally, a Cube bootloader needs to be installed here. This is so that at the beginning, when the PC starts up, we have the option if we have multiple operating systems. And here I have to choose the primary device for it, meaning the hard drive. In this case, it's also our virtual hard drive. So now it takes another moment. That means the setup is being completed. The entire installation is now finished, and then there will be a restart. So the system is now largely installed. As I said, now there's a restart, and after that the system is actually ready to use, but it is advisable to perform a complete update and upgrade immediately after the first start. This means that all packages are up to date and that we are not working with old system data. At the beginning, we log in with our user and the password. After the system has booted up, we open a terminal window and enter sudo apt update. We confirm this with our password, and the next command is sudo apt upgrade. All the old packages are being replaced again. This will take a moment. Now the upgrade is also complete. I can repeat both commands again. That means I do sudo apt update again. This should run relatively quickly now. It says here, all packages are up to date, and the upgrade should also result in everything being up to standard here. Okay. This is the moment when you can shut down the machine again. And now, I will copy this folder here. That means I will create a copy. In case something goes wrong, I can delete the folder and reactivate the copy instead, having exactly this starting point and saving myself from having to reinstall everything if something goes wrong. Okay, now we can, so to speak, start to continue. I would now configure my network adapter right at the beginning. That means I open the settings of the virtual machine, select network, and activate a second adapter. And here I specify that the whole thing is a network bridge, and the endpoint is my USB to Ethernet adapter. Confirm with OK, and we start the machine again.
So we can see up here that something is moving. That's because we now have a second network adapter. I can edit the connection with the right mouse button, and I will now delete this connection and create a brand new one, specifically an Ethernet connection called Internet, and I select my first device here. This is the adapter that is also connected to the Internet, so I'll save the whole thing and try it out right away. That means I'll search here for Linux CNC EtherCAT GitHub. And in this repository, there are already a few commands that we need to install the EtherCAT master. That means I can scroll down here and see the commands and also the other files that I need to adjust so that the EtherCAT master configured. But first I will change the display. That means I will choose a suitable resolution to get a bit more desktop space here, there. So as already mentioned, we need a few commands from this. There is also a step-by-step guide in the Linux CNC forum if you search for it. At least I've seen it before, and maybe it's linked here as well. Let's take a quick look. So there are several step-by-step guides on how to install the EtherCAT master here and, let's say, put it into operation. And that's also the approach we are aiming for now. That means we will simply execute the commands one by one. An important point here is that in the Linux CNC image already the package sources are included. That means we do not need to add package sources, but it is enough if we open a terminal and here copy and execute the commands. That means with Control-C I can copy them, right mouse button paste, I can paste them and can start simply installing the Linux CNC EtherCAT master. So the first step is done. I have already scrolled down a bit here. The next step is the configuration of EtherCAT, and for that we ultimately need the MAC address, which we get with IPA. That means we can then copy the MAC address from the network adapter ENP0S8, which is not configured at the moment. And now we need the second command, sudo niani, etc. EtherCAT configuration. This essentially opens the EtherCAT configuration file, and inside we need to specify which MAC address should be used for the EtherCAT master. That would be our USB adapter. And which driver should be used for that? We use the generic driver. That means I can simply copy the word here and insert it in between. Now I save the file and can close it again. Now, so to speak, the EtherCAT is configured for the time being, and next we will activate the service here. We enable the whole thing, so to speak, by working here with sudo systemctl enable EtherCAT service, and we say the whole thing should also be started. That means I execute the next command here. Inserande in CNC EtherCAT. And I do a sudo change or chmod so that we can access it now. You see, in the end, it's just copying and pasting commands, and now we're already done. Now we can hear apply voltage to the slaves, and we can check if we are with EtherCAT slaves.
See our terminals. So we see our terminals are active. And are recognized. So this is the step necessary to generally install the EtherCAT master, put it into operation, and already see the first slave. This means at this point the system would now be functional. However, the problem will be that we still need to create a rule and which is described down here. That means we will create an additional rule with this command, which ultimately allows us to access the EtherCAT device after the restart, I would say, so that Linux CNC also gets the opportunity to access it without issues, without permission problems.
Okay, we
check EtherCAT slaves again. All there except for one. It probably has some error right now. I'll remove the power again. Okay, all slaves are recognized that are currently on the bus. We will now use the Linux CNC example configuration from Axis. I open it. A folder structure is created here, including the files, and I can work with that. So that means I have a machine that starts, and I want to implement the EtherCAT master there. To do this, now open the configuration folder, and I have prepared an example so that it doesn't take too long by using copy-paste commands. The first thing I do, I open the ini file here and navigate to the HAL files section. That means all HAL files that are loaded are listed here, and I will add a test HAL, or if you prefer, VirtualBox HAL. So this whole file I am creating it now. I will just say here in the folder, right click, create new file, EtherCAT, and inside I will now write these commands from my example. One thing is, so to speak, the call from the configuration, the EtherCAT conf XML, which we will create shortly, then the whole thing will be loaded. And there is a read and write access through the functions in the servo threads, so they need to be loaded in order to read from the bus and write to the bus. And then I will also connect a few pins from an input module so that we can see that it works. Okay, I will save that. As already announced, the next file is I'll copy the name here. The next file I create is an EtherCAT conf XML, and in this file I will now so to speak, map the bus. That means we have a master that runs in the reference clock, that is in the servo thread. And inside there are some participants that are now described rudimentarily on the right, because we have already included the drivers. This means that when I write it in here, EtherCAT already knows what's going on, because there are already drivers for these devices. Someone sat down and wrote drivers. For all unknown devices, I naturally have to write much more here, like which registers are retrieved, which registers are written, and so on. That will be a really lengthy XML file, but for this specific case with these EtherCAT terminals from Beckhoff, the drivers already exist, so I can actually write them directly in here. For those interested, on the GitHub repository, there are the devices, and you can check which EtherCAT devices are already supported out of the box, so I don't have to think about it. Okay, I will save the whole thing. That means we now have an XML file, we have a HAL file where the whole thing is called. We have also already linked pins together. I want the inputs to be able to turn the machine on and off. And in the ini, we have also included this EtherCAT HAL. This means theoretically we can start the machine. And the first thing we can do is under HAL display, we can search for the EtherCAT. That means we have LC EtherCAT here, and under 0 is what we configured in the XML. That means the adapters appear here, and we can take a look at these pins. We can click on these pins here, and I would like the 4 outputs as well. There. I did the following. I have now connected the input module with the output module using a bridge. And if I set an output somewhere here, then the first pin on the last input module, this one here, should change. Or 0. This is simply the wire bridge that we see here. That means the output bit dampens the input. And then I have already, let's say, linked pins with this machine on, machine off, and I can do that here now. That means I can turn the machine on and off here, but only when the emergency stop is released. So I'll remove the emergency stop here. And now I have the button up here, which I theoretically operate by hand with the mouse, but I can also dampen it here with the input. So I can already turn the machine on and off here. Just as a small example of how to take the first steps with EtherCAT. As already mentioned, there is it on GitHub. I don't know if I can go back here now. Yes, on GitHub, there is the possibility to look at everything for the capable among us. They can here see how such drivers are written to create a simple XML that we can then use here. Otherwise, as mentioned, you really have to put quite a bit into it to make it capable, so to speak. But the bus is running without causing major problems, I would say, even in the virtual machine. Okay, we have already reached the end. So You have seen it's not hard to install EtherCAT. I think that's the smallest part with the 2 or 3 lines. The rest is necessary anyway. At the beginning to install the operating system here, so Linux CNC in general. And I think the difficulty comes later when you want to connect non-standard devices, meaning devices that don't yet exist in this driver database. Then it gets a bit tricky, I believe. But if you use standard things that are already used in there, maybe from eBay and such, shoots, then you can be confident that you can start it up without problems. Okay, that's it for now. I hope you could take away a little something and I could ease your fear a bit about trying it out. EtherCAT is not a bad choice. There are more and more used devices. Also, in the Chinese market, new EtherCAT devices keep appearing, sometimes even quite affordable. Okay, I don't want to drag out the video. A huge thanks again to all the Patreons who make this possible. Also thanks to everyone who watches my videos. Leave a subscription, a like, turn on the bell so you don't miss the next video. And then I say goodbye. See you in the next video.